What's up, y'all? This is Hussein Nasser from IGeometry, where we discuss software engineering by example. And I've been cracking a lot of content for this database series that I've been making for the past few weeks, really, and it's really cool. So we're on the isolation uh, concept of the ACID database, ACID. Properties, right? So we discussed a lot of things, and I'm gonna reference the videos right here. I've been pointing actually. Right there, up. Yeah, it's right there. Okay. So we discussed read uncommitted. We discussed read committed, and we discussed all these phenomena that we get. And then what do you solve with these approaches? What with this style of implementation? What kind of problems do you solve? So we find that read uncommitted is still happening in all of these. Right, we still have dirty reads, we still have non-repeatable reads, we still have phantom reads with read uncommitted. Read committed, we solve the dirty area, dirty read problem. We did not fortunately solve the non-repeatable read and phantom read. So read committed, where we actually read only committed values, right? And the latest at the latest timestamp, regardless. So the final one is actually, it's kind of a weird name, but I wish they give a better naming here to this. But it's called repeatable read. Repeatable reads. So repeatable read is another style of implementation here to fix these three problems, and we'll find out how it works and what it does and what problems does it tackle by actually just working through our example here, which is Instagram. We're gonna go into it in a second. And yeah, what repeatable read is, it is the read committed plus some other thing, some more overhead to um, to allow us to fix these problems. So repeatable reads is always read committed values, but also when you start the transaction, when you start the transaction, remember that version of the database and always read that version of the database, okay? Whether version is actually an actual version of the database or actually timestamps. That's a little more popular implementation by using timestamps of, so each record, each write, each committed write, each committed write actually creates a new version of that record. So you still can go back in time and read previous versions of that record. So that's enough babbling, and let's just do examples like we always do in this channel. How about that, guys? Let's do that. All right, so we have Instagram schema here. That's not the actual schema. You're probably right, guys. It's not. No, it's not two tables. I even don't know if they are using relational or not. Okay, so yeah. So we have two tables: pictures table with one picture and looks like two likes, and the likes table, which actually shows that this picture has been liked by two users. So we are consistent. Looks we're consistent. Nicely done. So what we're gonna do here is just try to see, does the repeatable read fix the dirty area problem, right? But to do that, we need to actually start some sort of color coding that actually tells us which version the database is in. And let's say the black, I don't know, just maybe, yeah, let's just say. So black means version 1. Okay, so that's, or maybe you can say version 1. So that's the current version, okay, of that. Think of it like version or timestamp, but we are in version 1 of the database, and it looks like this now. This is what our version 1 looks like. Okay, and we're kind of color coded. Hopefully we don't get confused with all the colors, but yeah, we'll try. So version 1. Mr. John Mr. John, yeah, let's say Mr. John. Okay, we're trying to tackle multiple things at the same time. Okay, Mr. John is trying to update, right? He's trying to make a like to this, to perform a like to the picture number one. Okay, so as you can see, he's already performed that like. So what will happen is this like will fail because of unique constraint, because of these puppies. So let's go ahead and just make this color orange. Let's keep it green. And then Sansa is trying to like that picture. Not like, actually. So what Sansa is doing is actually querying the pictures table. And she want to know how many people like this picture, just how many likes this picture has, right? Okay, so let's go ahead and execute. So what will happen here is Sansa will get, actually, since she's a reader, she's gonna get version 1, and version 1 is black, right? So just for simplicity, she's reading only version 1s, and that's very important. Okay, she's reading version 1. Cool. So John is trying to insert a like, so he's trying to like that picture. What does this statement mean? It is basically an update and an insert, right? So we're gonna update pictures, set likes count equal likes count plus 1, where picture, which is where ID is equal 1. Cool. And then after that, Sansa will come in and actually just reads the likes. How many likes does this picture have? Selects like from pictures where ID equal 1. Cool. That's orange since she's, but look at that, she's reading from version 1. So we'll see how this is actually working. And yeah, John continues executing some more stuff. So he's trying to insert a record, insert into likes, values 1 and John. We know that will fail, right? And then what will happen is she's gonna continue reading that again. So let's just see, this is this first, the dirty read. So Sansa reading version 1, John. Okay, let's execute. What will happen? So he's executing that. This will change like a new version. Now so John start to actually write a new version here. So what will happen is that version is version, so that is increased to 3. Cool. Let's just call it version. So this is no version really yet, so let's just like increase to 3. And then she queried, and remember, she's querying a certain version, so she's querying 2 still, regardless if it's committed or not. She's querying a committed version, which is a version 1. So she got, what did she get, man? She get 2. That's nice. And then, so now this succeeds. This fails because we're trying to insert that, which caused a rollback, right? A rollback, which basically deleted that version or that dirty read. And now, dirty entry. And then he's querying again the likes table. She is getting the same value because she's reading version 1. Cool, cool. So we don't have dirty read because we don't read stuff that are not committed. So we get this by default. We get this for free. Okay, now let's change this a little bit. So John changed that guy to Eddard. And that's, let's say, the same sequence of statements are happening here, right? Cool, cool. That changes. And then this guy's name is Eddard. And then what Eddard does is he actually commits that transaction. he attempts to commit that. What will happen now? So we query that, right? Nicely done. We update that statement. So we'll change that to green. Okay, we're making a change. And then Sansa reads that table, and guess what? She's reading version 1, so she's using only black values. So what she does is actually reads that. She got 2, and then Edward continues liking the picture, which is the second statement, which is let's just basically insert another row here. What will happen is we're gonna insert a new row, and obviously its name is Edward. That becomes, guess what? That's a green, and that succeeds. The statement succeeds, and then he actually commits, which is just commit. He commits that. Says, okay, I'm happy. I just committed that. Commit actually does now creates a version for us, which is version 2. Guess what? This is an official version. So we have version 1, we have version 2. They are both stored, so you can think of the overhead at the database level. We're storing different versions of the same thing, the database. So this is kind of an overhead, right? So we have historical temporal data. Okay, so now we insert that statement, change that, it's all good. Sansa still reads committed rows, however she reads this particular version of a row, unlike the read committed. That's just an overhead, over an overall. She doesn't read any committed value. She doesn't read the latest committed value. She reads the current version she starts with. And she started with version 1. She is a powerful woman. Alright? She gets what she wants. Hashtag feminism. Okay? Alright, she started with version 1. She keeps reading version 1. Guess what? Yeah, she gets her version 1 value, which is 2. Cool-ish, guys. Cool values. How about that, guys? How about that? Alright? So we just fixed 2 problems. Dirty areas, and also we also fixed the non-repeatable read. Does this fix the phantom read though? Well, let's find out. This is like kind of controversial, but let's find out. So let's change this statement to select select star from likes. Give me actually the likes of this, the actual users. Alright, so she turns around here and actually execute the same query. Frame likes where ID equal 1. Okay, what should we get? Execute that. Execute that. She's reading version 1 still, right? So she's gonna get, this was not committed yet, she's gonna get 2 records, one, John and Sansa, and then Edward actually commits, but he's committed version 2, and she's querying from version where ID is equal 1, but she's only searching versions now. It depends on the implementation of the database, really. This might actually get a phantom read or not. It depends on the implementation. So if she queries and she's querying only version 1, I better only get these. So I would just say that we fixed the read committed, the phantom read with this as well. So we actually just check the whole boxes here, guys. We fixed that. We don't get dirty read. We don't get non-repeatable, and also we don't get phantom reads. I'm gonna put a question mark here based on the implementation, because really maybe if you're versioning that, if you're getting an extra record, so we have to actually get that version. We only read the value of the version. All right, so that actually in addition to the where here, there will be some extra where clause that is added by the database, which obviously gives us another head, right? And version is equal blah, right? Or versions is equal or less than one, anything, because we also want to read previous versions, obviously, not only versions that are written in version 1. Does that make sense, guys? Again, feel free to discuss this and let's talk about it more. All right, and yeah, so that's basically concludes our isolation topic. It was really long series, right? And the next episode we're gonna discuss durability, right? Durability, where if I write something, it better stay written. Okay, guys, like this video if you like it, subscribe. It really means a lot if you write comments here. Means to me that you are actually interacting with this video, talking to each other in the comment section, learning and learning more and more about software engineering. That's the message I'm trying to send here. Learn as much as possible in a fun way. We try to be fun. I'm not really a fun person, but nerdy stuff. But trying to make it light as possible, as simple as possible, guys. So yeah, stay awesome and like this video. See you in the next one. Goodbye.